Okay, this is Coach Williams again, and we are going to do the notes for 5.1. This section is going to deal with systems of linear equations, and so for our first vocabulary term, we'll say, we're going to define what a system of linear equations is, and it's going to be a set of two, put in parentheses, or more, because there could be more. For this particular this particular section, 5.1, we're going to deal with mostly just a set of two or more linear equations. Two or more linear equations. And when we have two linear equations, unless they are parallel, they're at some point they're going to cross each other, and that's what we're after here. This is what we're looking for. This is going to be called the solution of the system of linear equations, where the two lines actually cross. So when we see two lines and we've got one here and one here, where they cross, that point of intersection is going to be the solution for both equations. So it's the solution to the system. In other words, it's an ordered pair that you could plug into one equation and it makes it true. You could also plug it into the other equation and it makes it true. And could you not have three lines that intersect at the same point? Sure. You could have multiple lines intersect at the same point. And if they do, then that point is a solution to all of those lines, however many lines you have. That's a solution to all of those equations of those lines at that intersection point. All right, so the solution of a system of linear equations is an ordered pair. It's an ordered pair that is a solution of each equation in the system. Okay, it's an ordered pair that is a solution of each equation in the system. It has to be a solution of every equation in the system. In this case, like I said, 5.1, we're going to deal with two equations. So it must be a solution for both equations. All right, and if it is, then that is a solution of the system of linear equations. Core Concepts just talks about kind of the steps in which we'll find out the solution to these systems. And in this case, they're going to do it by graphing. So if we can graph the two linear equations on the same coordinate plane, if we can graph each equation on the same plane, then we should see a point of intersection, and we'll estimate that point of intersection. Our lines may not be exactly perfect. Mine won't be perfect. But we can kind of get an idea, well, we think it should be at, x equals this value, y equals that value. And then we can go and take that ordered pair, plug it in or substitute it in for x and y into each equation in the original system, and if it makes both equations true, then we know that that ordered pair is a solution to the system of equations. Alright, so that's kind of the steps. That's how we're going to look at it. That's how we're going to approach it. And let's go to the next page and we'll kind of get familiar with checking or substituting in an ordered pair into the equations or into the systems of equations. Alright, so right here they're going to give us, I'm going to go ahead and move this up a little bit, they're going to give us a possible solution. It's an ordered pair. They want us to find out whether or not this is going to be a solution or not to this system. So it's real simple. We're just going to plug in 3 and 1 into these equations, into both equations, and see if it makes them true. So for the first equation, we'll just put a 1 out there. For the first equation, we're going to have x plus y equals 4. Well, where there's an x, we're going to put 3. Where there's a y, we're going to put a 1. And we're going to say that equals 4, but does it in fact equal 4? Let's see. 3 plus 1 is 4, and 4 does equal 4, so that one checks out. All right? And then we're going to look at the second equation. And the second equation, we'll do it in a different color here. The second equation is going to be, and I'm not going to fill out the whole equation here. We know it. We can see it right there. Let's just go ahead and plug in our values. 3 for x minus y should be a 1. We're going to see if that equals 3. Well, 2 times 3 is 6, and 6 minus 1 is supposed to equal 3, but we know that it does not. 6 minus 1 is 5, and so that does not equal 3, so this is a no. This is a no. 5 does not equal 3. So 3, 1's not a solution to this system of linear equations. Let's move on to the second one and see if we can make this one work. Alright, so for the first equation, we're just going to substitute in a 1 and a 3 where we see x and y. And so we're going to have 1 minus 3 is supposed to equal a negative 2. Well, 1 minus a 3 does equal negative 2, and so negative 2 does equal negative 2. That checks out. Then our second equation, we're going to have 2 times 1 plus y, which is a 3, is supposed to equal 5. Let's see if it does. 2 times 1 is 2, plus 3 is supposed to equal 5. 2 plus 3 is 5. So 5 does equal 5. This is going to be a yes. Okay, that is a solution to this set, because it makes both of them true. Okay, moving on to the next one. We're going to have, on the first one, we're going to have, and they did this a little bit different, 0 is supposed to be equal to 2 minus 2. And we all know that anything minus itself is just 0, so that one checks out. And then for the next one, 0 is supposed to equal negative 3 times 2 plus 6. Well, negative 3 times 2 is a negative 6 plus 6. And again, anything minus in itself is just going to equal 0. So 0 does equal 0. That also checks out. And this is a yes as well. Is this making sense to most everybody? Pretty simple. We just plug them into both equations, make sure that they do equal each other, and if they do, it's a solution to the set. If they don't, then it's not. Let's look at number 4, 5, and 6. I tell you what, you work 4, 5, and 6. I'll do it on the board here on the overhead, and you determine whether or not you believe they are or not, and then we'll confirm answers here in just a minute. So I'm going to give you some time to work on that. I'll be working on it up here, and we will check answers in just a minute. Okay. If you have not finished working these out, you can obviously pause the video if you want to go back and finish working them and then check your answers. But you can see here on number 4, we should have a yes. When we plug in a -1 in for x and a -2 for y, -1 minus 2 times a -2 will be -1 minus a -4 or plus 4, and that does equal 3. So that checks out. 2 times a -1 minus a -2, it's a -2 inside there, is -2 minus a negative is plus. So -2 plus 2 is 0, so that checks out. That should be a yes. Number 5 is a no. The first part works out correctly. It is a solution to the first equation, but it's not a solution to the second one. And so, because it doesn't work out here, this is 2 times a -2, which is -4, 4 times 3, which is 12, and 12 minus 4 is 8. 8 does not equal 9. So that's a no. And then number 6 is a yes. When we plug in 4 and -3 into both equations, they both check out. Okay? So that's an introduction to how we actually substitute the values in and check the equations, which we're going to need to use as we move forward. We're going to look at the graphs. We're going to estimate a point or a location, and we need to check that location to make sure that it's going to work. And so we need to know how to plug those values into the equations to make sure that they work correctly and they are a solution to both equations, or in essence the set or the system of equations. Alright, so now, number 7. Let's move on to graphing, or looking at the graph and trying to determine a solution based on the intersection point on the graph. Alright, so when we look at number 7, what does it appear is our solution to the system of equations? What does it appear that on number 7 is our solution? It's the point where they intersect. What does it look like it's going to be here? What's the ordered pair? We're going to have 2, -2, right? It's that point right there. So the x value should be a 2. We'll do it this way. The x value should be a 2, and then we're going to go down to -2 for y. So it should be 2, -2 should be our point of intersection. Now we can check that again like we did in 1 through 6, and we can confirm that. So we could say that 3 times 2 minus 2 times a -2 is supposed to equal 10. Well, 3 times 2 is 6, minus a -4 or plus 4, plus 4 does equal 10, so 10 equals 10, that checks out. That's the first equation. Let's try the second equation. On the second equation, going to be pretty easy. 2 plus a -2 is supposed to equal 0, and it does. 0 does equal 0. So that is our solution. By looking at the graph, we can see the intersection point, and using that coordinate, that ordered pair, we can plug it into both equations and check it. What about number 8? What does it appear the answer to number 8 would be? For x value, we're going to go back 1, so that's a -1. And we're going to go down 1, 2, 3. So -1 and 3 looks like it's going to be the solution to this set. It's where they intersect. Alright, so let's look up here and let's try this. -1 minus 2 times 3. Well, 2 times 3 is 6, and -1, I'm sorry, it's supposed to be -3. Yeah, -3. -1 and -3. So this is going to be -1 minus 2 times a -3. 2 times a -3 is a -6 minus a negative plus. So -1 plus 6 does equal 5. So that one checks out. And then 2 times a -1 plus a -3. So it's a -2 plus a -3 does equal -5. So that one also checks out. So this will definitely be our answer. -1, -3. Alright, on to number 9. Number 9, the intersection is right there. And that is at what coordinate, what location? 4. And then the y value should be a 2. And if we plug that in, 4 plus 2 times 2, which is 4. So 4 plus 4 is 8. So that works for that one. 3 times 4 is 12, minus 2 times 2, which is 4. So 12 minus 4 is 8. So it checks out on that one. So the solution to our set on number 9 is, in fact, 4, 2, the ordered pair 4, 2. Okay, and you can show more work down here, plugging those in and making sure, confirming those. You can use your calculator to plug in the values and make sure they work out as well. All right, let's flip the page. We're going to look at number 10 through 15, and here we're going to have to graph them ourselves. So they're adding one step every time, right? They don't give us the graph. They don't give us a point. Now we have to actually graph it and find the point and then check the point, make sure it works. All right, so if we're going to graph the first equation, these are already in the form of, and we'll just kind of write this down here, they're already in the form of y equals mx plus b, right? They're in, let's write it up here, y equals mx plus b. And so we can pull the slope and the y-intercept out of these equations. Now we get down to number 12, we'll have to do a little work. But for the first two, they give it to us in that form. So, that being said, what is the slope of the first equation? The slope should be what's in front of x, and that's just a negative 1. The y-intercept is what's after the x term, and that's going to be a positive 3. So can I graph that equation? Yeah, absolutely. I can go up to the y-intercept of 3, put my first point there, and then I've got a negative 1 over 1 slope. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and I can draw that line on my graph, and then subsequently draw the other one and see where they intersect. So here, I can draw this line, and there is the first equation. Now, what about the other equation? What is the slope and the y-intercept for the second equation? The slope on the second equation is just going to be a positive 1. The y-intercept is what? Positive 5. Okay? So, positive 5, we can go up on the graph to 5. And then here I've got a positive 1 over 1, so I've got to go up 1 and over 1. And I'm going off the graph here, so I'm going to reverse here. I'm going to go down 1 and back 1, down 1, back 1, down 1, back 1. You get the idea here. And then we can draw that line. When we draw that line, you can see the intersection point appears to be what? Negative 1, 1, 2, 3, 4. So negative 1 and 4 is the point that appears to be my solution to this set. Now let's just look at it real quick and just test this. A negative 1 is a positive 1. And positive 1 plus 3 is 4, and y is 4. So that does check out on the first equation. A negative 1 plus 5 is also 4, and y is 4, so 4 does equal 4, and it checks out on that one. So my solution to this set is a negative 1, positive 4. Not too bad. Let's look at number 11. We'll work it the same way. Let's get the slope and the y-intercept of the first equation. Slope is going to be what? 1/2. The y-intercept is going to be 2. So let's graph this one. Put our point on x equals 0, y equals 2. That's our y-intercept where it crosses the y-axis. And I'm going to go up 1 over 2, up 1 over 2, and reversing down 1 and back 2, down 1, back 2. Okay? And so then I can draw the line for that equation. All right, and then for the second equation, what is the slope and the y-intercept for it? The slope is a negative 1/2, and the y-intercept is 4. So I'm going to go up to 4 and plot my y-intercept point there. And this time I'm going negative 1 and over 2. So I'm going to go down 1 over 2, down 1 over 2. And I could go back this way and repeat the process, reversing my signs there. And then I'm going to get this line right here. And I've got an intersection point, and that intersection point right there, like we had here, should be this solution to this system. And so this should be at 2, 1, 2, 3. So at 2, 3 should be my solution. When I plug this into this one right here, 1/2 of 2 is 1. 1 plus 2 is 3. And 3 is what y is supposed to equal, so that one checks out. Negative 1/2 of 2 is a negative 1. Negative 1 plus 4 is 3, and y equals 3, so this one checks out. That is my solution to this system of equations. All right, number 12, well, they do one favor for us, and then they make us work a little harder for it, I guess. They give us this equation, y equals negative 3. What is y equals a constant? I had people in the previous classes giving me the hand motions as we were doing this on overhead here. They were giving me, oh, it's horizontal line, coach, horizontal line motion, right? At y equals a negative 3, I can just draw a horizontal line. Draw a horizontal line. That is y equals a negative 3. And that's pretty easy. There is a 0 slope, and that's the only way x goes away. As you multiply it times 0, then the x goes away. All right? And so then now we just have to work out number 12, first equation. And it's in standard form. They gave it to us in standard form. We just need to get it into the slope-intercept form so that we can pull out the slope and the y-intercept. All right? So let's rewrite it over here. 3x minus 2y equals 6. And now let's isolate the y term, or the y variable there. And first thing we have to do is move this 3x to the other side, right? And when we go across the equal sign, it just means we change the sign of it. So this would be a negative 2y is going to equal, moving that across, it's going to make it a negative 3x. I'm going to rearrange the terms so it's in order of this y equals mx plus b. We still have the positive 6 over there. So all we did was subtract 3x from both sides. Now I'm going to divide by negative 2. Divide by negative 2. Divide by negative 2. The negative 2 over negative 2 becomes a 1, so we just have y. Negative over negative is positive, so we have 3 over 2. And 6 over negative 2, or 6 divided by negative 2, is the same thing as a negative 3. Now I should be able to pull out my slope and my y-intercept. The slope is going to be 3/2. The y-intercept is a negative 3. That's convenient. That's convenient because now right here is my y-intercept for the first equation. And that looks like it's going to be the intersection point for both equations. I'm going to go up 3, 1, 2, 3 over 2. Up 3, 1, 2, 3 over 2. And I can draw the line for that equation. That's a little off there. It's all right. And draw the line for that equation. And I can see that my intersection point is right there. What is the value at that point? It's 0, negative 3. And it makes perfect sense because if we had an x term in here, we put a 0 there and make it go away. And y is negative 3, and negative 3 equals negative 3. If I put a 0 in for the x term here, and negative 3 times negative 2 is positive 6, positive 6 equals positive 6. So they check out on both equations. That is the solution to this system of equations. All right, 13, 14, and 15. On number 15, we are going to use a calculator at this point, or at some point there, to help us out. So let's just write down here, we're going to use calc on that one, just to remind us when we get there. Number 13, they do us a little bit of a favor as well. They give us y equals 4x, which is pretty simple to graph because the y-intercept is just 0. It's just like having plus 0 out there. And the slope is going to be 4. So at 0, 0 is our y-intercept. Then we go up 4, 1, 2, 3, 4, over 1. 1, 2, 3, 4 over 1. And that is going to be the graph of the first equation. So we'll put that on here. And then the graph of the second equation, the slope is a negative 4. The y-intercept is 8. And so when we plot the y-intercept, we should be right here. And then when we go down 4 and over 1, we come to this point here. Down 4 over 1 comes to that point there. And so then we can graph this equation. And we should have the intersection point pretty obvious. And it's going to be at 1, 4. So at 1, 4 should be our intersection point for these two equations. And we can go back and test that, obviously. If y is 4 and we multiply 4 times a 1, we both end up with 4, or we end up with 4 on both sides. If y is 4 and we're supposed to equal 4 here, then negative 4 times 1 is a negative 4. Negative 4 plus 8 is a positive 4, and positive 4 equals positive 4, so it checks out. This is our solution to this system of equations. Okay, on to the next one. The slope here is 1/4. The y-intercept is 3. Pretty easy. So we can go here. 3 on the graph is our y-intercept. We're going to go up 1 over 1, 2, 3, 4. I'm going to go back by going down and then obviously over 4 here. And then I can draw the line for this one here. And then on the second equation, the slope is going to be 3/4. The y-intercept is going to be 5. And so I'm going to go up here to 5. And then this is a positive 3 over 4. But if I go up and over, I'm going to be off the graph here. I'm going to go backwards. So I have to go down 3 and back 4. So down 3 and back 4 puts me right there. And that gives me 2 points on my graph. I can go ahead and graph that line here. And so there is the graph of both lines. And my intersection point is right there, which is at what location? Negative 4 and 2. Negative 4 and 2. And if I plug those into both of these equations, I find that it does solve for both of those. Okay? Alright, and then the last one, we mentioned we'll do this on the calculator, so I'll get to that in just a minute. But we need to get this into y equals mx plus b format before we can put it in the calculator, and also before we could even graph it if we wanted to. So the first thing we're going to have to do here is we're going to have to get this into slope-intercept form. Slope-intercept form. And so we need to take the first equation, 3x minus 4y equals 7. And we need to get that in y equals mx plus b format. Okay, so let's take the 3x and move it to the other side, right? We're going to subtract it from both sides, or just move it, and when you move it across the equal sign, it changes the sign. So then we'll end up with negative 4y is equal to, and we'll put the x term in front, negative 3x plus 7. We just moved it from here to there. Okay, we just moved it over. Alright, now we're going to divide by negative 4. We have to divide every term by negative 4. Those negative 4s will go away. Y is going to equal negative over negative is positive. So 3/4 x. And then minus 7 over 4. I'm going to leave it at that right there. I'm going to leave it at that right there. And then we're going to work the calculator magic here in just a minute. Alright, let's work the second equation. We've got 5x plus 2y equals 3. Again, we're going to move the x term over here. We're just going to take it and slide it over there. When we do that, changes the sign. 2y is going to equal, in this case, we'll rearrange it as well, negative 5x plus 3. All right, then we're going to divide by 2, divide by 2, divide by 2. So now, 2's go away, y is going to equal negative 5 over 2x plus 3 over 2. Okay, and again, I'm just going to leave it in this form at this point because I'm going to put this into the calculator, and we're going to see if we can't find the solution using the calculator. And we'll come back and show the graph as well. All right, so now, our calculator, if we take the calculators, if you've got those, make sure you turn it on, and you're going to go into y equals, all right? Y equals, and I've already got it in here. I'm going to clear this out just so we can show you how to put it back in. But if I go to y equals, which is the button right here at the very top left, I can put in these equations. I can put in this equation here and this equation here, and I can graph them on the calculator. I mean, wouldn't it be kind of difficult to plot negative 7/4 and then do the 3/4 slope with that, and then plot 3/2 and do this negative 5 over 2 slope? Yeah, it'd be kind of difficult, right? It's doable, but still, we can do this in a calculator, and it makes it a lot easier for us, okay? So if I'm putting this in the calculator, y equals 3/4x minus 7/4. All right, so I'm going to put every fraction in parentheses, just a habit that I have. It kind of keeps everything cleaned up. So if I put negative 3/4 in parentheses times x, x is going to be the button right beside alpha. Then I'm going to minus, and again in parentheses, 7 divided by 4, close parentheses. I'm going to hit enter. That's my first equation. If I wanted to jump over here and hit graph, you could see that equation graphed right here. Okay? But I need to do the other one as well so I could see both of them and see where they intersect. So I'm going to go back in here to y equals, go down to my second equation. I'm going to put in a negative. Make sure you're using the negative sign, not minus. It's going to be a negative 5 divided by 2. I'm going to put that in parentheses. 5 divided by 2. All right, so then it should look like that right there. Or you could have the negative inside, doesn't matter. And again, I'm going to put x. So you need the x term in there. This time we're going to add another fraction. Again, parentheses, 3 divided by 2. And that should be my two equations. And when I graph those, you should see those on this particular calculator in two different colors. Yours will just be the same color, and most likely. And you're going to notice here there's an intersection point right there. What does it look like it's close to just whole numbers if we're looking? Looks like it's at 1, right? X is 1, y is negative 1. It's pretty close. Pretty close, but it's hard to tell, right? And we're not real sure because there's some fractions involved there, and it kind of scares us a little bit. We could hit trace and move along this graph, this line, and you can see we get pretty close to a positive 1 and a negative 1 for y, but it doesn't give us exact, points there. So there's one way we can tell for sure. If we go second graph, it actually takes us to the table. You're going to notice some values for x, and then it's going to give you the y values that come out when you plug those x values in. Now what we're looking for is the same x and y value for both equations, right? And so I'm going to look for an x value over here on this side and a y value on this side that's the same on both of them, right? Both equations. Does anybody see the same y or the same output value when I put in one of my x values? At positive 1 for x, you get a negative 1 in the first equation. You get a negative 1 in the second equation. That's the same point. 1, negative 1. So 1, negative 1 is the solution to both equations. So it's the solution to the set. And so we can go over here and we can say 1, negative 1 is my solution. If I were graphing that on this, I would do my best, because remember we're dealing with fractions here, but the first equation is at negative 7/4. Well, that's negative 1 3/4, right? So negative 1 3/4. Okay, then I'm going to go up 3/4. I'm going to go up 3 and over 4. So 1, 2, 3, and over 1, 2, 3, 4. I'm going to go right in that area. Okay, it's pretty close, right? So I'm going to go right through there. Right, and the other one's at 3/2, a little easier. 3/2, or 1 1/2, right? And this one I'm going to go down 5. 1, 2, 3, 4, 5 over 1, 2. So I'm going to go there. I'm going to do this in different colors so it stands out here. And again, when I draw my line going down through here, I'm going to pass through that area right there. And if I plug in these values, 1 and negative 1, into both of these equations, they do check out. So negative 1, or 1, negative 1, is the solution to this set, or this system of equations. All right, and that's how you can use the calculator to help you find it, by going to the table and looking for the values that match in your y column for the same x value. Okay, we'll see more of that as we move along in the next section. Let's work the last problem on the notes, and then you'll be done with this. We'll be able to go on to the practices after this. A test has 20 questions. 20 questions. And they're all going to total 100 points. Okay? The test consists of X, true, false, and 4 points for each one of those. Y, multiple choice questions, and they're worth 8 points. Okay? How many of each type of questions are on the test? We actually have 2 equations in this word problem. First of all, we know there are 20 questions. How do we get to 20 questions? Well, we add all the x's, however many x questions there are, however many y questions there are, and it's going to give us 20 questions. But then we also know that 4 times the x, the number of x questions we have. Let's say there's 5 questions, so 4 times 5, right? We have 4 times x plus y's worth 8, right? 8 times y. We know that all of those points added together are supposed to equal how many points? 100. 100. So I have a system of equations. Can I graph this and solve for it? Sure. Yeah, absolutely. Can I get y by itself here? Yeah, minus x from both sides, right? So if I minus x from both sides, y is going to equal negative x plus 20. Can I graph that on this? Absolutely. My y-intercept is 20. I'm going to go right up here on 20 and put a point. My slope is a negative 1. So I'll go down 1 over 1, down 1 over 1. If you'll notice, down 1 over 1 is a 45-degree angle. It just goes right across over here to 20 on the positive, on the x-axis. So I can draw a line right there from 20 to 20. All right, that's the first equation. The second equation, I got to do a little bit more work. Then I'm going to move the 4x to the other side. So I'm going to have 8y's equal to, what happens to the sign here? It changes. And then I got to divide by 8 every term. And I'm going to end up with y equals negative 1/2 x, because negative 4 over 8 is negative 1/2. And 100 divided by 8 ends up being about 12.5. So it's a little tricky, but not too bad. If I go to 12.5, now in the middle there's 13, so I got to go kind of in the middle of the middle. And then now, here's the tricky part. I got to go down negative 1 over 2. Negative 1 over 2. Negative 1 over 2. And I'm going to keep going here. And you'll notice if I kept going, I'm going to end up crossing right about there. Okay, if I kept going, I'm going to cross right there. So if I draw that line, that's the graph of the other line. Well, that's right at The x value of what? 15. What's the y value? 5. So my solution to this system of equations is 15 and 5, meaning I have 15 true, false, and 5 multiple choice questions. That's how many of each type I have, totaling 100 points. And doesn't 15 plus 5 equal 20? So I've solved both equations, right? 15 plus 5 is 20. That's how many questions are supposed to be on it. 15 times x and 5 times 8 is going to give me 100 points. All right, that concludes the notes for section 5.1, and you will be able to work on your practice now. So I hope you have enjoyed the video and that it helps you get started and understand this section of Chapter 5.